certain columns or rows, and those rows or columns you are interested in, you can also do that by subsetting. So maybe you want all the rows and all the columns of your data. You want to display all the rows and all the columns of your data, or maybe you are interested in a specific one. That you can also do. Right. So that is how you import data and be able to display it.
Hello, sir.
Hello. Maybe you can, yeah? Go ahead.
Yeah, please. So how do you display the entire data?
So display.
Okay.
Okay, display. So we need how do you call it? Let me just do this. Hold on. From let me convert it to a data frame. Let me just say df equals pd dot data frame of data. So you see, it's if you watch what I just did, I'm trying to display it, right? Can you see some 3 dots here?
Yes, please.
Yeah, so we are trying to display the data, but you know, this data has so many observations.
Yeah.
So listing them with two, so it use those 3 points to indicate that, yeah, there are some data which is there, and below it, it tells us how many columns we have and how many observations, which is the rows. So it gives us the number of rows and the number of what? Columns. Does that answer your question?
Yes, please.
Okay. Any other question? Okay, so if there are no other questions, then we will start the lesson that we have for today, with your permission. Okay, so.
All right, Samuel. So let me lay down a few housekeeping and then we can start. Yeah, so please make sure that you fill the form for the attendance for us so that we can count this as attendance for you. And I'll be posting the attendance form in the chats. Also, let's make sure that we are following up on some of the announcements, all the announcements that are being put in the group. These are very important announcements that we have to follow up. Next week, we are going to have data science class, and that is going to be a very important part of the course. Arranging your data and coming up with the table and the data to feed the machine learning is the most important part of doing any machine learning exercise. It's the most tedious part as well. That's the part you need to sit down and properly structure things. And so next week, let's all endeavor to come early and to have the class. If it's too much and there's a spillover, we are going to go into the next week for that. But for today, let's continue our lecture with our facilitator, Dr. Senyo. And then if there are any questions, let's put it in the chat box. If you can unmute too, you can interrupt him at any time, and then you can ask your question. But this is a recorded meeting. And so what it means is it's not everything that you have to stop your teacher. You can always go back to the video and watch it. So if the thing is not really something you need his attention right now, but it's a step you missed, there is always opportunity to go back to it so that we can have as much as possible to record. All right, so Dr. Senyo, it's time to have you. I'm trying to let us start 2 on the dot so that we don't miss the people that will be entering at that time. And so please set up for today and let's enjoy the class. Thank you. I'll be posting the form in shortly.
Thank you. I'm sure you
One more
have.
thing, Dr. Senyo. So this is the Young African Scientists platform. I think I've not been introducing the professional body to us, to some of us that have just joined. This is the Young African Scientists platform. Young African Scientists is a professional body that is set up to support you with training and with training in various areas. And we are also going to have professional presentations from different angles. And so you can go to the website yaslinkup.com and you can see a lot of things. Now, if you go to yaslinkup.com, you can also visit the engines page to register for the course. But everyone is supposed to have a professional code. If you check your email and if you have registered for some time now and you don't have your code, check your email. If you check your email and it's not there, check your spam. If it's not there, contact me on WhatsApp or contact me here and I'll try and find your code for you. That's what I'll be doing in the time for the lecture. So thank you very much, Dr. Senyo. Please take over.
Thank you. So with that said, we zoom in straight to Python for data science. A few things that we'll be doing. I have a slide. I thought about, I don't know what to be the best. Maybe I should get some advice. This is the slide we're using today. I wanted to share it, but I was thinking maybe we'll go through it together and you also be generating it on your side. But maybe at the end, I'll share the slide with you. Maybe I'll do it that way. what would be the most efficient one? Tabiri? Share before the class, or because I'm thinking if I share, people will not be able to do it. I want them to do it. What would be the best way?
So I think both. Maybe somebody wants to open it and follow you, and if they miss something, they can look at it without disturbing you.
Oh, okay. But I'll share this with I'll share this with you, and then they can also have it.
Then I'll share it in the group for them.
Yeah. Yes. Yeah. Yes. Okay. So the first thing, which I would say is that whenever you want to perform any function in Python, even in R and other softwares, and you need a library, you need to know what library do I need? Because if that library is not imported, you will not be able to perform that particular function. With time, you will get to know what library do I need to import for me to be able to perform certain functions. Right. So the first thing that I want us to do here is to, first of all, import data. So please open your Python. Please indicate if you are struggling to open Python so that I can help you. Because that is the first thing. Please open Python. If you have a challenge opening Python, please let me know. I'll quickly go through that because I need you to have your Python open, just as you can see it. You can, even if it's empty. What I want to see from you is something like this. It will be like this. If you are struggling with this, please let me know, and I'll quickly take you through that. Anybody who is struggling, all of you should have something like this. If you are struggling, just quickly indicate. I'll give you just 30 seconds to indicate. If I don't hear any comment from anyone, then I will assume that we have all been able to open it. Okay, I'm not getting any comment, so I assume that all of us are here. So once we are here, the first thing that you want to do is to import this library. So let's import the library. So you start by typing import pandas as PD. You do that. Then the second library is a Seaborn, and then Matplotlib is for data visualization. Those two are for data visualization because we want to draw some graphs. So if anytime you want to plot graphs in Python, you will need these packages or these libraries. So because somewhere along the line, I will be plotting graphs, I want to import these libraries. But if I don't have to plot graphs, then I don't need it. Because I want to plot graphs, that is why I am importing it. So you go import Seaborn as SNS. When you do that, you want to go to the next one, which is the Matplotlib. You just press enter. Then again, import Matplotlib dot pyplot as plt. You can even end here without putting this. This is just to add some nice background to the graphs, right? You can even end here without that. So once you have that, you can see that this particular cell is the one which is selected. What you need to do is to run it. So let's run this cell. How do we run it? We just go to this where I put my cursor, and we can see that the moment I put my cursor there, it says run this cell in advance. Run this cell in advance, which is the shift enter. So that means when you run this cell, it must go to the next cell. So when I run this, if I were to take it to a new cell just for you, when I run this, it takes me to the new cell. So this is what you have. Now, the next thing I want to do is to import the data. So you have been given the data. We need to import. How do we import the data? Now, to import the data, I said earlier on that you need to know the path. You recall how to get a path, isn't it? Anybody who is having a challenge getting a path? So you copy the path. So I have my path here. This is my path. Yours will be different from mine. So you don't expect this to be the same as yours. My path and your path will be different. This, what I've highlighted, is where my data is. That is this folder. This folder. This is where my data is. This is the automobile data that I want to open. But when I click this is my path that I have put there. If I were to put another one, this is my path. But when you open the path, you realize that there is one backward slash. You can decide to go with the backward slash, but if you decide to go with that, there must be two. You must double it. You must double it. You must double them. Each one of them must be double. Or if you don't want to go with two of them, you can go with one front slash, which is what I am doing here. Now you put that in quotes, but the data that I want to import, what type of Excel file is it? It's a CSV file. I know it's a CSV file. So I need a function in Python that imports CSV files. And that function that imports CSV file is called read_CSV, is this one here. But the library that will help me to be able to use this function is the Pandas. That is why earlier on I invoked it. So this PD you see here is the same as the PD that you see here. It's the same. So pandas.csv, I have my path. Then after the path, I introduce another forward slash. After that forward slash, I now put the name of my data. What is the name of my data? Automobile. I'm sure you all have it. Automobile. But what type of file is Automobile? The automobile is a CSV file. So I need to state that. So that is why I have CSV here. And if you watch, I put all of these in quotes. It doesn't matter, it can be double quotes or it can be one, it doesn't matter. It can be one, it can be two. For the purpose of the just demonstration, I will use both quickly. So double here, double here, double here, double there, double here, and I will call this auto double. So I will import. I'm taking this down because I don't need this. I just copied it. I don't need to run that. So I'll import this data and I'll import this. I'm doing the same thing but using different approaches. So if I want to run what is here, now after writing all of this, what is this? What is this auto? That auto is a name I have given it. I am calling that data by a certain name. I just chose auto because the data is called automobile data. So you can decide to call it whatever name you want to call it. You can give it your own name if you want to. Right. So I call it auto. So I'm assigning the data I'm importing a name, and the name is auto. So I need to run this, and when I run and there's no error, you will see that it goes to the next what cell. So this data is imported. If I want to import this one also the same way, I just run it, and that is also imported. So both of them are imported. But we are only going to go with one. I was just doing the two because I wanted you to see how both of them will work out. So I'll comment this one out. Remember this, I said this is how you comment something out. If you want to comment something out, you put the hash sign before it and it's commented out. So I've imported the data successfully. That is the first step. Earlier on, we said we want to look at the first few rows of the data. Now, so what is here? The auto you see here is the name of the data. Let me take this down. So this auto you see here is a name. So whatever name you call it is the same thing you put here. Now head is a function in Python, which gives the first 5 rows of your data. So when you run this, it gives you the first 5 rows. Now, after we have, you can check rows, columns, whatever. You can do all of those things. But let's begin to do something interesting. You can use the thisplot function or the hisplot function to look at certain graphs. So the first thing that you do, normally when you have data and you want to perform whichever machine learning algorithm you want to use, you start with some basic univariate distributions. Univariate meaning you are looking at individual variables. You want to look at those individual variables and look at what type of distributions they follow. So individually. So in this case, I'm looking at that. So I think I can work here now. I can work here so that I don't keep copying. Now this is drawing a histogram. Now, when you run that, let me do something for you to see. This is a function that is used to draw a histogram. Now, if I were to run this, watch this. If I were to run this, it gives me that, isn't it? It gives this a histogram that we have. But I am using a variable called highway_mpg. I can also use this plt.show to display it. It doesn't matter. So I can do it two ways. Now, which variable am I drawing here? Highway_mpg. So what you see here, remember this here, this first part here is a function where from this SNS, from here, from the Seaborn package, that is why we call it SNS. We are calling it SNS. In that package, there is a function called histplot. So I'm calling that function. I'm explaining for this one. So the rest, it will be the same thing. So you just follow. So I'm calling that function, which is there is in that library that I have imported. And I'm saying that, look, perform a certain task using that function on a certain variable. Now, what variable do I want to perform it on? On the highway MPG. But what is this? This is the data. So in this data, I'm saying that in this data, when you go to this data, pick this variable from this data, which is auto, and execute this function on it for me. But that is the meaning of that code. For those who are conversant with R, what would have happened is that dot, which you see there, would have been a $sign in R. A $sign comes between the data and the variable. So what you see here is auto is the data frame that you're working with, and highway MPG is the variable. So in this data, I want you to perform this function on this variable. And hence you have this. You get it? It's the same scenario that we are doing here. Again, we have data. This is the data. But now in this data, there's also a variable called highway MPG. I want you to perform this function on it. So let's start with this. So have you done this? Do this first and see if you're able to get this plot. If you're not able to get a plot, just let me know and then I'll guide you. I'll give you 1 minute because it doesn't take much time to type that. Were you able to get a plot? I hope so. Now, so for the next plot, it's similar. So you just need to know the functions that you need to use to execute a certain task. Now, there are times where you find this, there are warnings, but you can just ignore it. They're just warning. But there we have it. There is some distribution on it. So distribution plot of this. This is just the histogram. But now we have a distribution plot also on the imposed on the histogram. Right. We can have another plot. There are so many plots you can do. There are so many plots you can do. There's so many you can do. So I'm doing between horsepower and engine size. I just chose them arbitrarily, right? I just chose them to see the joint plot of these two variables. So the data that I'm using is auto, yes. On my x-axis, I want engine size. There is my engine size. And on my y-axis, I want horsepower. There is my horsepower. But this is that. Okay, this is what I did there. We can also decide to look at multiple pairwise scatter plots in a data set. So you have a data set where you want to look at the relationships among certain variables, the scatter plot. And this must be for the numeric variables, because you can have categorical variables also in your data. But for you to draw scatter plots for multiple data sets, you only do that for the numeric variables, the continuous variables. You don't do that for the categorical variables, right? So if you want to do that, this is a function. So if I take you through the function again, this is a function which is in CBOL. I want to do this, I want to execute this function on these data sets, which are called auto. Remember, earlier on, the name of the data set is called what? Auto. So anytime you see auto, that is the name that you gave it. Whatever name you gave it is what you work with. But I want this plot for certain types of variables, for this, that, and that. Now, when you look at this is normalized losses, the first one, engine size, horsepower. It tells you that relationship between each of the variables. So this, if you look at the one up here, is a relationship between normalized loss and engine size. This one, this scatter plot here. This one here is a scatter plot, or the relationship between horsepower and normalized losses. This here is a relationship between engine size and horsepower. So it's horsepower and engine size. All right. So it takes you to that kind of bivariate relationship between variables. You can do this for more variables if you wish to. These are the preliminary things that you normally do before you even start your actual process of building whatever model that you want to do. You may decide to have when you have categorical variables, you can also do some plots of those categorical variables as well, because these plots here, these scatter plots here, are only exclusive to numerical variables. You can have categorical variables and you may decide to do plots of them. So I have fuel type and horsepower. So the horsepower is numeric, but the fuel type, maybe you have two types of cars. One uses gas and the other uses what? Diesel. And we want to look at the distribution of the horsepower for gas, for fuel, for cars that are using gas, and for cars that are using what? Diesel. So if you watch here, this is categorical and this is numeric. It's just like, for example, you have a class where you have categorical variable, maybe male and female in the class, and they write a test. and the test they wrote is numeric. So the marks that they scored is numeric. So this is the marks for the student, and this is the gender. We can do the same thing. We can do the same thing, but now using box plots. I'm sure you all know what box plots are. So we can draw a box plot. So as the name here, box plot, the data is also again, these, the number of doors, and this is the horsepower. These are variables. These and these are variables in the data, which is called octo. Maybe, sorry, if I'm going too fast, let me know. Am I going too fast?
I think so. I'm sorry. I think there was a little bit of speed from the pair plots to the categorical, stuff.
Okay. So do you what will you want me to repeat? Or do you want to do this one? Should I give you time to do this?
Yeah, I was hoping so actually.
Okay, okay. Then try it. Try it. Let's see. Try and see if you can get the same plot as I have there. Even though I'll share this slide with you, but try and see if you can also do the same. Just type, do it as I have there, and see if you get the same result. But make sure that you have followed the process, you have imported the data, you have imported the packages and the data before you even get here, right? I'm sure those ones you've already done. Are you getting the result? Is it all good? All right. I see a thumbs up. Okay, so we can go to the next one. So try this. There are different plots that you can do, depending on what suits you or which one you prefer. You just go for it. So I just put a couple of them here. This is not exhaustive. There, you can decide to add many more plots to this. Okay, were you able to just replicate, sorry, to replicate this? Good. Now let's look at the box plot. So this is a box plot. I want to draw a box plot of horsepower for different number of doors. So again, this part here is a function to draw a box plot. I want to draw that on using the data auto. For my x, I want this variable which is categorical, and for the numeric variable, I'm interested in the horsepower. You can choose any one that you prefer. There are so many variables here. So when I run this again, this is what you get. You can see number of doors. So there are 2 doors and 4 doors. I'm sure in the next class you will go through what this means. This is a box plot, right? I'm sure we all know this box plot. You know, this is the median value, isn't it? This is the first quartile, this is the third quartile, the minimum, the maximum, and these are the whiskers. And that which is there is an outlier. So this is an outlier. That is also an outlier. I think you will do more of these in the classes, subsequent classes that will come. But this is the box, but this is how it looks like. It gives you a distribution of the variable. So this is how a 2-door horsepower car has its distribution, and this is how a 4-door car horsepower is distributed. There is another plot. So if you look at it, number of doors, horsepower, number of doors, horsepower, but we are adding something to it. See what happens. So there is fuel type. You see, we have number of doors, and then we have what? Also fuel what? Type. So there are some that use gas, and there are some that use what? Diesel. So we are now complicating our what? Analysis. So for this number of cars that use 2 doors, some of them use fuel, and some of them use gas. The same way for the ones that have 4 doors, some of them use gas, and some of them use what? Diesel. So I'm now complicating the analysis a bit. So try this also. Let's see if you're able to produce this. Okay, can I move on? The same way, we can also draw bar plots. We can draw bar plots as well. And the function that we'll use to draw bar plot, again, is that. There are error bars. You can see the error bars, right? So I'll send you all of this. this note. So you can draw it with or without the error bar. So this one produces the error bar. The other one here will not produce the error bar. So try this first. Please note that whenever we write the variable names, they are always in quotes, right? You must always do that. So like body style, there's underscore because that is how it is written in the data. So you must write the variable name just as it is in your data set. All right, so this is also basically doing a similar thing, but the only difference is that it doesn't now produce the error bars that you see. This doesn't produce the error bar. It's still also doing the same thing, but just that this now doesn't produce the error bars. Right. So these are just some basic graphs that usually when you want to do any analysis, you start with basic descriptive statistics. You have some graphs. Of course, graphs are very important when you do any analysis, and that is what we just started with. We've not touched on any machine learning yet. We've not started with anything there yet. These are just the preliminary steps that one will usually undertake before starting any machine learning process, right? I'll skip these two, I'll come back to it. If you want to perform a heat map, so you see sometimes earlier on we did this, but let's assume that I want to now draw a heat map of the
Hello, Dad. Hello.
Hello, yes.
Yeah, Doc. I want
Right.
to go after executing this function.
Which
You
one?
want to, yeah, you want to save. How do you do it? You want to save this identical word.
What do you want to save, please?
The
graph or the whole
yeah,
thing?
the graph.
Oh, if you want to save this graph, you see, just right click on the graph and see the various things you can do.
Okay.
Right click on it. Yeah, thank you.
No,
Thank you for the
I'm
question.
following it. I'm not with my computer. My computer has problem, but I'm following a lecture on my phone.
Oh, okay. So if you right click, if you can see, when you right click,
Yeah.
there's so many things that you can copy and do all of those things.
Okay.
You can save it as an image, JPEG, whatever you want to do.
Okay.
All right.
Thank you.
Thank you for the question. Yeah. So let's assume I want to do a heat map of certain variables. Right. So My data I know contains both numeric and categorical variables. So I'm interested in some variables that I want to draw a heap map for. And remember, in doing this, you only do for the numeric variable. So I select those ones. So what I'm doing here is basically doing subsetting. So I go to my data, integer location. Now look at it. When you look at this side is saying I want all the rows, but what is here are the columns I'm interested in. Those are the locations of the variables I'm interested in. So I'm interested in number 1, number 9, 10, 11, 12, 13, 23, and 24. But I've just saved this as auto1. So when I run that, so try that. Please try that. Try that code. What I'm basically doing there is selecting those columns, right? This one, that one, that one, and that one. I'm selecting them because those are the ones probably I'm interested in. They are the numeric ones of interest to me. Are you done with this? Okay, so if you are done with this and you run it, let's just see the variables that I have selected. These are the ones. These are the variables that I have selected. Normalized losses, wheelbase, length, and whatever. Let's say these are the variables that I'm interested in that I want to draw a heat map for. Right, so that is the code. Now look at it. There's the heat map. I'm just giving the size of the plot. And if you watch, I save this data as auto1. So that is why here there's auto1 here, because I extracted those data and I save it using a different name called auto1. So that is why you see auto1 there. If I run that, hooray, this is what it gives me. You see, this is something that you are familiar with, right? There is a diagonal one, there's a correlation coefficient, because this is between the variable and itself. Sorry, let me just do this. Just give me a second. Let me do this. Okay. I'm sure you can see my screen again. So that these diagonal ones are the correlation between the variable and itself. So that is why they are 1. So you see, normalized losses is this one. This normalized loss, 1, 1, 1, 1. All the ones on the diagonals are the correlation between the variable and itself. Now it just gave it color, and you can see here. These here are the correlation what? Coefficients between the variables that you have what? Drawn the heap map for. So these are some of the nice things you can do, but please take note, this is for the continuous variables. Do you want to try that quickly before we move on to the next one?
Sorry, I have a quick question. By continuous variables, do you mean numerical variables?
Numerical variables, yes, numerical variables, exactly.
Someone is asking, what's the meaning of the dark correlations?
Okay, so you see, correlation is from -1 to +1, right? Now, when it is +1, so let me speak to the colors. So if you watch carefully, just watch the colors as they are here. They're yellow. These colors here, they correspond to this. There's a legend here. If you can watch the legend here. So this legend, the yellow here, which is close to this one, is saying that the correlation between those variables are 1. So there's a perfect linear relationship between those variables. Then, if it's not very perfect, it's between two variables that are not of the same type, it will be dropping down. So you see this one here, where my cursor is, 0.88. That is the relationship between wheelbase and length. It is somewhere around here. It's somewhere around here. Then you just need to watch the color and look at the legend. So this is 0. Everything here is positive. So watch carefully. Everything here is positive. So the yellow, I'm not very good with colors, so please, you pardon me, right? But everything from here all the way here is positive. The moment you go down, it's negative. So the dark one is a negative relationship because it's down here. So you need to watch this and watch the legend. So if you look at the dark ones, this is dark, this is dark, this is dark. These are negative significant relationships. And when there are negative relationships between variables, what it suggests is when one of the variables is increasing, the other one is decreasing. Just like, for example, your income and expenditure. For some people, the more they earn, the less they spend. So when their income is increasing, their expenditure is decreasing. That's a negative relationship. Is that okay? So that is the dark one. The black you see is down here and it's negative. You can see these numbers here are negative. This is a legend that you should use to interpret what is here. These ones are positive. All good? Good. Let's go to the next one. So for the data that we have, the auto one data that we have, we can just have some basic descriptions of that data. We just want to describe it. So the auto one is the name of the data that we are dealing with now. Describe. We want to describe that data. And what does that produce? Look at what it produces. The mean, standard deviation, the minimum, the 25th percentile, the 50th percentile, which we know is a median. So if you recall, this 25th percentile is this one. Is this one here. This is a 50th percentile, and this is a 75th percentile, which is what we have produced here. 75th percentile. This is a maximum, and this is a minimum. When we come back here, this is our minimum, and this is our maximum. This is just an outlier. So that produced that. The mean, we know what the mean is, isn't it? We know what the mean is. Right, so this is just describing quickly how, describing our data. This is just another way of doing the same thing we did earlier on, but now with different colors. So I won't go through this again. The last thing that I wish to touch on before we leave is whenever you have data, you need to prepare the data for your modeling. And there are so many ways of data preparation. You would have a very nice time with one of the tutors who will take you through this. Very good person, excellent person. You enjoy that, but I'll just quickly touch the surface and she will go deep. So we need to go some data preparations. And depending on whichever field you are, but in most cases, you find that every data has some missing data. So you want to find out the type of missingness you have. You can even calculate the ratio, the percentage of missing data in each variable. And when you notice that there is missing data, what do you do? Right? There are two ways of handling it. One way of handling missing data, which is the easiest but dangerous, is to delete whatever missing data you have. Just delete it. Deletion. Completely is gone. But if you don't want to delete the missing data, you want to do something about it, then the second approach, which is mostly used, is to impute. So what does impute mean? To impute missing data simply means to replace it. And there are several ways of doing this. You'll be taken through this at a later time. There are several ways of replacing missing data using different data imputation methods. Right. So for the data that we have, let's say for the auto data, so no, the auto, let's use the auto one data. We have highway MPD. Let's assume I want to perform a regression using this data. And my target feature, my dependent variable is highway MPD. That is my dependent variable. Meaning that the rest will become my independent variable or my features, my input features. Remember we said earlier on, there must be an input feature that you use. Now you need to prepare this data for your modeling process. And one way is to select your independent variables and to select your dependent variable. So what I have here, I call it X. So X here is referring to my independent variable. I'm saying that in my auto1, that's the name of my data. I call it auto1 data. What do I want to do? That means in this data that you see here, what do I want to do? I want to drop a variable. What do I want to drop? I want to drop this one, which is my dependent variable. So when I drop this, I'll be left with all of this. So that is why you see highway MPG in bracket. Now, as this equals 1 says that it's referring to a column. So for it's when it's 0, it's a row. When it's how do you call it? When you are dropping columns. So what I'm trying to do here is I'm trying to dropping a column. Now, in dropping, a column, this as this equals 1 refers to what? The column. If I were to drop rows, then as this would be equal to what? 0. All right. So what column do I want to drop? I want to drop this highway MPG because that is a dependent variable. So I'm calling this will be my independent what? Variable. Then for my dependent variable, which is my y, I am saying that for this data, I need this variable. So my y is this, my x are that. So I have been able to separate my dependent variable and my independent variable to start with. Let me take this out. Now, for every regression or for any machine learning algorithm that you have to undertake, something is very important. You need to divide your data into either 2 or 3. You can decide to have your training data and your testing data. You can decide to have a training data, a validation data, and a testing data. But in most cases, we go with the training and the testing data. Now, in getting your training and your testing data, you need to divide the data into 2. The rules depends on you. Some people use the 80-20 rule. 80% of the data used for training your model and 20% to test or to validate your model. Some also use 70-30. So you can decide that I want to use 70% of the data to train my model and use 30% to test my model. Because every model that you train, you must be able to test it and see how effective is the model. You want to assess the effectiveness of that model. And there are some metrics that you use to determine whether your model is good or not. You'll be taken to those metrics. For regression, there are some metrics. The R-square, the root mean square, root mean square error, the mean square error, and a whole lot. If you are involved in the classification algorithm, you can have the receiver operation curve characteristics, the receiver operating characteristic curve, the ROC. You can look at sensitivity. you can look at a whole specificity. You can look at a whole lot of things. You can do that for both the training and the testing data. But what I want you to understand here is that when you have data and you are to undertake any machine learning, you need to divide your data into training and testing. And to do that, you need these to do. You can, I was using others, so I was doing a whole lot of things, so I can limit it to this, only this. So you see, from sklearn model selection, import train test splits. This is what you use. This is a package or the library that you are going to use to divide your data into training and testing sets. Earlier on, you identified your X and you identified your Y. So my X train is the training data for the independent variables. My X test is the testing data for the independent variables. Your Y train is the training data that you are using, the dependent variable that you are using for your training data. And then the Y test is the dependent variable that you are using for your testing data. So basically, this X train and Y train will be used to train the model. The X test and the Y test will be used to test or validate the model. Test size, you can see I put 0.30 here, meaning that I am using the 70-30 rule. If I decide to use the 80-20 rule, then I must change this to 20. That means I'm using 80% of the data to train my model, and I'm using 20% to test my model. But before I do that, I need to run this. Then I run here. So now I have my training data and my testing data, and I can use it for my modeling process. I can use it for my modeling process. Now, after you have your training and your testing data, there are times where you have to standardize your data. There are times where you need to standardize your data. Maybe I'll give you should I give you something to read on? You go and note the difference between standardizing data and normalizing data. You can normalize data and you can standardize data. But what I'm talking about here is how to standardize data. And this is a very important step that you would have to undertake when you are doing machine learning. And what it does is it transforms the data, the numeric one, the numeric variables, so that they will have a mean of 0 and a standard deviation of 1. So when you are standardizing the data, what you are basically doing is to transform the data so that it will have a mean of 0 and a standard deviation of 1. And to standardize data, you need this library to do that. You need this library to do that. And that is what I'm trying to do here. I'm calling it. So this is my data, auto1. I'm saying it's a data frame. I just gave it a name df. Then I'm calling the function standard scalar. So this function is what is used to standardize the data. But I have given that function, I've assigned it a name called SC. So when I call SC here, I am actually calling this. So instead of writing this whole thing, I'm just calling it a name and I'm putting it here, SC, into fit underscore transform. What am I transforming? The data set, which is the DF. That is why I have DF here. I'm scaling it. So when I run this code, did I run it? Yeah, I think I ran that. When I run this, see what it produces. The normalized ones are here. So these are the different variables. So what it has done is it has transformed my data to have a mean of 0 and a standard deviation of 1. There are other things you can do, so many things you can do. We cannot exhaust them before you start the actual machine learning process. I put this there, but I will not go into this for today because the time is even far gone. But depending on what you're doing, there are hyperparameters. I think you'll be taken through hyperparameter tuning. So these here will be good for grid search, which try to select a different combination of parameters that you need for whichever model you want to do, if you want to do support vector machine or whichever one. So you can do grid search, you can do random search and different ones. You can do all of those things. You can do cross-validation and all of those things. So there are so many things you can do before you start the actual modeling process. And once you do those grid search, those hyperparameter tuning, you can decide to tune so that, because the whole purpose of tuning this hyperparameter is that for whichever metrics you are interested in, you want the one that will give you the, if you're interested in the accuracy, you want the combination of hyperparameters that will give you the highest accuracy. If you were interested in the root mean square error, then you want the combination of parameters that will give you the least root mean square error. So you can select whichever metric you want to use for the hyperparameter or tuning and all of that. Right. So I'll pause here. If you have any question, you may please ask. Thank you.
Hello, sir. I just want to find out, when you were splitting into training and testing sets, there was an argument, the random states. Can you please explain a little about it? What does it mean?
So you see, when you run codes, what happens is that, you see, when I run this again, I can run this 2 or 3 times. The data that we are generating from, remember, we are taking data from X, which is this one, all these variables, and Y, and we are putting them into different S-train and all of that. So this random state, which is just giving a value 1, it controls the number of variables that, the number of observations that we have used to shuffle the data before splitting it. It ensures, basically, that the same randomization is done. So that the same number of observations is chosen anytime we run the code. So the same split, you get the same split. I don't know if you understand. Because if you don't put it there, if I run the code, it may select this one, this, and that. Now, without this, when I run the code again, it may go and select another set. It will change it. You get it? But once I put this random state there, whatever it selects the first time, it keeps selecting the same splits.
Okay, I think I understand. But so when it's not there, what will be the implication?
So what the implication is that, so when I run the code, I'll get the result. Is that okay? Now I have saved it. If I run it again, my result may change because it may go and pick different combinations again. So there will be slight changes in my result because the, how do you call it? The splits that it is using for the S train and the Y train, the first time I run the code may change slightly in the next time I run the code again. So I want it to be consistent, to be selecting the same split again and again and again. So that is what that is doing. So it's a very important parameter that you need to put in trying to split the data. Thank you for that question. Is it clear?
Yes, sir, it's very clear.
Okay, thank you. It's a very good question. It's just there to control the randomness of the data. Because you see, at first, it's just select the data randomly. So we want to control that. We just want to control that. We want to produce the same split again and again and again. That random state is the one that controls it. Any other question? Okay. So if there is no other question, I think we can end here for today. And I will share these slides with you, and you can practice for this whole week before the next class.
Yeah, thank you very much, Senor. I think for many of us, this is the first time probably we are beginning to see Python being used to plot graphs. Most of us have been using Excel, SPS, and other stuff. So this is a good way to come into the environment of Python and use it to plot graphs. And you're going to plot a lot of graphs in your machine learning because you need to tell us or tell your audience correlations in your data and all that. So the important thing is that you're taking through the process. The point is not to memorize the code. This document will be shared with you, and you can always go back to the video and follow the steps to plot your graphs. And you don't need everything here. You only need 1 or 2 or 3 things for the work that you do. And not just for machine learning, you can also apply this to your research. If you want to plot 3D graphs, you want to plot heat maps, you want to plot different correlations with error bars, this document provides the avenue for you to be able to do so. And so this is a very useful tool that Senor has taken us through. The attendance link is there. Please, once you have come, just mark it for us. From next week, we are going to add another important feature where if you don't come for the class, you can go and watch the video and answer some simple questions that somebody who has watched the video will know. Once you answer those questions, then we can mark you as present. And so from next week, any of the videos you have missed in the past, you can go watch it and then just answer those questions for us on that video, and we can mark it for you as attendance. We know some of us are busy, some of us have classes, some of us might be somewhere else when the lecture is going on. So we are trying to provide different means for people to be able to also be a part of the course. So thank you very much for joining us today. This is still the Young African Scientists platform. And from next week, we are going to look at data, get the data, clean the data, work on the data, and then begin to apply the machine learning to our data. So thank you very much for joining us today. God bless you and see you next week.